A report from the National Confectioners Association shows Americans buy more than 2 billion pounds of hard candy each year. That mountain of sugar could fill thousands of trucks lined bumper to bumper. Unlike fresh fruit that spoils in days, these tiny sweets can sit untouched in a jar for years without losing their shine. How can something made from sugar and water defy time itself? And what hidden steps turn boiling syrup into the wrapped candies that once rattled in every kid's pocket? Hard candy first appeared in Europe during the 1600s, when sugar was still a luxury item. Apothecaries combined herbs with boiled sugar to make lozenges for sore throats. By the 19th century, industrial sugar refining made candy cheap and abundant. In the United States, general stores displayed jars filled with colorful drops, sticks, and lollipops. During the 1950s and 60s, kids could buy them for just a penny. Striped candy canes at Christmas and lollipops at county fairs became symbols of simple, affordable pleasure. These candies were more than treats. They were part of everyday American life. The journey begins with sugar, corn syrup, and purified water. Stainless steel kettles hold more than 500 pounds of ingredients per batch. Steam coils heat the mixture until it boils. At 300 degrees Fahrenheit, 149 degrees Celsius, the syrup reaches the hard crack stage. Most water evaporates, leaving behind a thick, glassy liquid. With almost no moisture left, bacteria and mold cannot grow, which is why hard candy can sit for years without spoiling. But that is only half the reason. It takes another hidden factor to keep these sweets lasting so long. After boiling, the syrup moves into mixers. Precise milliliters of flavorings, cherry, lemon, peppermint, are added. Food dyes turn the clear syrup into vivid reds, greens, and yellows. At nearly 300 degrees Fahrenheit, timing matters. Add too early, and flavors burn away. Add too late, and they fail to blend evenly. Industrial mixers rotate at 60 revolutions per minute, folding color and taste into every strand of sugar. Which flavor would you choose first? Classic peppermint or sour fruit? Comment your pick below and let us know. The hot candy mass is poured onto wide cooling tables coated with food-grade oil, which prevents sticking. Operators use long metal paddles to fold and flip the heavy, glossy slab, turning it repeatedly as it begins to cool. Each fold traps layers of air and keeps the sugar pliable instead of hardening too quickly. As the temperature drops, the slab is divided into thick ropes. These ropes are fed into mechanical pullers, equipped with rotating arms. The pullers stretch and twist the candy hundreds of times per minute, forcing microscopic air bubbles into the sugar. This process gives hard candy its shiny, opaque finish and a lighter bite compared to unaerated sugar glass. From there, the ropes are guided into precision cutting machines. Circular blades or stamping dies strike in perfect rhythm, slicing uniform pieces at high speed. A single cutter can produce up to 18,000 pieces per minute, roughly 300 every second. For standard runs, the shapes are discs, sticks, or balls. But seasonal production lines swap in custom molds: candy canes for Christmas, heart lollipops for Valentine's Day, or striped sticks for summer fairs. Each mold must be chilled and oiled so the sticky sugar releases cleanly without breaking. Freshly cut pieces ride conveyors into cooling tunnels. Air circulates at 68 degrees Fahrenheit with humidity controlled at 40%. These conditions prevent stickiness and ensure candies harden into glass-like structures. Tunnels stretch 20 meters long, giving each piece 10 minutes to stabilize. Sensors check weight and dimensions. Misshaped candies are blown aside by air jets and collected for remelting. Hardened candies drop into hoppers that feed high-speed wrapping machines. Thin paper or foil twists around each piece at 1,200 wraps per minute. For bulk packs, optical scanners remove defects before automatic weighing. Exact portions fall into bags, jars, or boxes. Within seconds, sealed packages roll onto pallets. A single line can prepare 50,000 pounds per day, ready for shipment across the country. And once the wrappers lock out air and moisture, that second safeguard explains why hard candy can outlast almost anything in your pantry. The candy is done, but the next story begins where few would expect. According to Statista, Americans consume more than 2.8 billion chocolate bars each year. That is nearly 9 bars for every person in the country. A single Hershey's bar costs less than $2, yet behind it stands an industrial system worth hundreds of millions. How does bitter cocoa transform into a sweet icon that shaped American culture for over a century? And what steps allow one factory in Pennsylvania to produce more than 70 million bars every day? Milton Hershey opened his chocolate factory in Pennsylvania in 1905. His goal was to make chocolate affordable for everyday families, not just the wealthy. By combining milk powder with cocoa and sugar, he created a unique flavor that quickly became the American standard. Hershey's bars were issued to U.S. soldiers during World War II, spreading their reputation across the globe. By the 1950s, Hershey's was no longer just candy. It was a cultural marker, present in lunchboxes, campfires, and school cafeterias across the country. Shipments of cocoa beans arrive from West Africa and Latin America. Each container holds up to 20 metric tons. The beans are roasted in massive revolving drums at 250 degrees Fahrenheit, 121 degrees Celsius, for up to 30 minutes. Heat develops the chocolate aroma and loosens the brittle shells. Machines then crack the beans and separate the shells from the nibs. A modern plant can process 5 tons of cocoa beans per hour. The nibs are ground into a thick liquid called cocoa liquor. Hydraulic presses split it into cocoa powder and cocoa butter. In refining machines, cocoa liquor, sugar, milk powder, and cocoa butter are blended. Steel rollers crush the mixture until each particle measures less than 20 microns, thinner than a human hair. The refined paste enters long troughs called conches. Heavy paddles knead the chocolate continuously for 48 to 72 hours. This removes excess acidity and smooths the texture. The result is a creamy mass with the distinctive Hershey's tang. No one enjoys biting into dull, grainy chocolate? Comment, agree. If smooth and glossy is the only chocolate worth eating. The chocolate is cooled, then carefully reheated in a process called tempering. The temperature cycles between 80 degrees Fahrenheit and 90 degrees Fahrenheit to stabilize cocoa butter crystals. This ensures the finished bars have a glossy surface and snap cleanly when broken. Without tempering, the chocolate would turn gray and crumbly. Tempered chocolate flows into molds shaped like classic Hershey's bars. Vibrating tables remove air bubbles and create smooth surfaces. Cooling tunnels solidify the bars in about 15 minutes. Then high-speed wrappers seal them in foil and paper at 1,500 bars per minute. A single line can package 1 million bars per day, sending them to supermarkets, vending machines, and lunchboxes across America. A million bars leave the factory, but what comes next is a pairing no one expected. According to Hershey's annual report, Reese's is the best-selling candy brand in the United States, generating over $2.7 billion in sales each year. That figure beats even M&M's and Snickers. Each cup looks simple, just chocolate and peanut butter, but it hides a delicate balance that machines must repeat millions of times daily. How can factories keep every swirl, layer, and bite consistent? And why did this one treat become the perfect marriage of sweet and salty for generations of Americans? Reese's was invented in 1928 by H.B. Reese, a former dairy farmer and employee of Milton Hershey. He combined peanut butter with Hershey's milk chocolate, creating a new kind of candy cup. During the 1940s and 1950s, its popularity soared. The mix of sweet and salty felt indulgent yet affordable. By the 1980s, Reese's had become a cultural icon, advertised through catchy slogans like, "Two great tastes that taste great together." Today, Reese's cups are not just candy. They are part of American tradition, found in lunchboxes, Halloween baskets, and movie theaters across the country. The story begins far from the factory floor, in tropical fields where ripe cocoa pods are harvested. Workers split them open and scoop out the wet beans. These beans ferment under leaves for days, then dry in the sun until their shells harden. Packed into burlap sacks, they travel across oceans to the chocolate plant. Inside the factory, machines crack the beans, separating husks from nibs. Giant grinders crush the nibs into a dark, flowing liquor. Mixed with sugar, milk powder, and cocoa butter, the liquor becomes the base of milk chocolate. Conching machines knead it for hours, smoothing flavor and texture. Finally, tempering aligns cocoa crystals, giving the chocolate its glossy snap. Every batch is sampled and tested before it moves forward. While the chocolate is being refined, peanuts arrive in bulk, roasted by the ton until golden and fragrant. They're cooled, shelled, and ground into a creamy paste. Caramel is blended in, creating a warm, sticky filling. The mixture pours onto wide belts, then heavy rollers press it flat into sheets. Cooling fans firm the surface so it can be shaped with precision. The peanut caramel sheets slide forward to cutting blades. In seconds, they're sliced into neat, bite-sized discs, each identical in weight and thickness. These will soon be enveloped in chocolate, becoming the heart of the candy. Some say the best part is the chocolate. Others say it's the peanut butter. Which side are you on? On another line, tempered chocolate flows into shallow cup molds. Spinning wheels coat the sides, forming delicate shells. The peanut discs drop neatly inside each cup. Then a second stream of chocolate spreads across the tops, sealing the filling beneath a smooth lid. Vibrating tables shake out air bubbles, creating a flawless surface. Cooling tunnels at 50 degrees Fahrenheit harden the cups within minutes. Solid and shiny, the Reese's cups roll toward packaging. Wrapping machines envelop each candy in orange-printed foil, sealing in freshness. Scanners confirm weight and graphics. Wrapped pieces drop into cartons, which are stacked on pallets and loaded into trucks. From there, millions of cups spread across the country, filling store shelves and candy bowls. According to IBIS World, Americans chew through over 150 million pounds of gummy candy every year. That's more than the weight of 400 fully loaded jumbo jets. Unlike hard candy that shatters, gummies bend, stretch, and snap back. Their texture feels playful yet engineered, and their shapes range from bears to worms to watermelons. How can gelatin, sugar, and color transform into chewy candies that never lose their bounce? And what keeps a Sour Patch Kid so tangy, it almost makes your eyes water? The first gummy candy appeared in Germany in the 1920s, when Hans Riegel founded Haribo and shaped fruit gum into tiny bears. By the 1980s, gummy bears had become an American childhood staple, joined by worms, rings, and neon shapes. Sour Patch Kids, with their tart coating, added another twist and quickly gained popularity. Today, gummies are not just candy but a cultural icon, sold in movie theaters, school stores, and Halloween bags across the United States. Factories start with sugar, corn syrup, water, and gelatin. Gelatin provides the chewiness, extracted from animal collagen and refined into powder. Large tanks hold thousands of gallons of syrup. Automatic systems weigh ingredients with precise sensors, ensuring every batch starts with the same ratio. Flavorings and acids, like citric acid for sour varieties, are stored separately, ready to be added later. Sugar and syrup are heated in stainless steel kettles to 230 degrees Fahrenheit, 110 degrees Celsius. At this point, gelatin powder is blended in, giving the mixture its elastic backbone. Mechanical stirrers spin continuously to prevent scorching. Transparent pipes transfer the molten mass to holding tanks, where operators monitor temperature with digital sensors. Only at the right temperature can the mixture flow evenly into molds without losing bounce. Starch trays act as molds, each with thousands of tiny impressions shaped like bears, worms, or kids. The hot syrup flows into these cavities by gravity-fed pumps. The trays stack and cool for up to 24 hours, allowing gummies to set. Once removed, they already hold their playful forms. Which gummy shape was your favorite growing up? Bears, worms, or something else? Share it in the comments. The gummies move into drying rooms with controlled airflow. Here, excess moisture evaporates, and the candies stabilize into their chewy state. Depending on the product, they tumble in large drums with sugar crystals, sour powder, or light mineral oil for shine. Each drum handles hundreds of pounds at once, coating every piece uniformly before packaging. Finished gummies travel down conveyors into automated bagging machines. Optical scanners remove misshapen pieces before precision scales drop exact weights into bags. Sealed packs tumble into boxes, which are stacked on pallets bound for supermarkets worldwide. The bags may look playful, but the bigger story behind every piece still hides more than most people realize. Each of these products, hard candy, chocolate bars, peanut butter cups, and gummies, shows how something familiar can hide an unexpected process. What looks simple on the shelf often requires enormous machines, strict precision, and hidden tricks to make it last, shine, or taste the same every time. For many viewers, these treats connect to childhood. A lollipop from a candy jar, a Hershey's bar by the campfire, a Reese's cup from a lunchbox, or a handful of gummy bears traded at school, each one carries memories along with flavor. It is a reminder that every bite tells two stories: the memory you hold and the factory steps you never see. Do you want to keep exploring the secrets behind everyday products? Hit subscribe to Captain Discovery now so you never miss the next episode.